So in this video, let's look at the time estimation of our neuron model based on the pin plan we have made. And let's look the path that take long time to signal to reach from the input to the output. So when you want to do time estimation, so we need to go to tools and then we go to time analyzer. So if you go to customers time here, so here if you have a clock, we're going to use this to see the timing of the clock, but this will go in the future videos. We'll talk about it, but let's look at the path, the general path that our signals takes. So we can start here. Yeah, so you see here we have our project name, and we are using Cyclone 5, and this is our board. So this is from the signal input name. So we're gonna choose our input signals. So all our input signals, so which is our axon and cinepass. Those are our inputs, and then they don't go through anything. We just go to outputs, and outputs our LED lights, count and majority detector. So we're gonna report number 10 is okay, and then we're gonna report path. So now automatically it's using a 1.1 volt at the high temperature, 85. So we can see this is our delay. The highest delay is from is 10 nanoseconds. This nanoseconds is from W0 to majority detector, and then here we can look the path that is taking. So let's first of all generate all corners. So there are 4 corner cases. Both of them are slow and fast. So we're going to talk about what is slow and fast in the future videos, but now let's just focus on the path. Now we can see here we have the highest delay comes when we have slow at the high temperature, where this is where you're going to have the highest delays. So you can see here the path of this highest delay is taking from the path is from our pin AD11, which is the third switch, to our LED light majority detector. So you can see here the path that is taking. So, and then the most delays come from for example here in this lab cell. So lab cell are logic array modules. Those consist of LMUs, and then they are organized in cells. So that's why you have you have X and Y position of each lab cells. So this will be different, depends on the compiler, how you have programmed it. So for example, if you change in the same code, if you change something, maybe it's gonna take a different position, and then you have different delays. So this is how you look at the delays, which path taking longest delay. So on the next video, we'll show how we can measure this on the oscilloscope, how we can find the highest delays, and then we verify on the oscilloscope.